Okay, some more problems from section 9.2, and again we're still constructing series and we're using the Maclaurin's table on page 491. So we're looking for x squared cosine of x, so we know the cosine of x is this series, that's from the table, so we just multiply each term by the x squared. And we do that, we get x squared, x to the fourth, and 2 factorial is 2, and then x to the sixth, and then 4 factorial is 24, and then same general term, negative 1 to the n, that stays the same, that stays the same, and then if I multiply x to the 2n by x squared, I just add 2, so that's x to the 2n plus 2. And since the cosine converges for all real x, so does x squared cosine of x. Okay, the next one, number 11. We wanted this as a series x over 1 minus x to the third. So I could factor the x out and say this is 1 over 1 minus x cubed. And I know that 1 over 1 minus x, that's my first series, and that's my geometric series, is just 1 plus x squared, x to the n. So I just substitute x to the third for x, or x cubed, and I got 1 plus x cubed squared plus x cubed to the n. That's my general term, and then that's going to be x cubed, x to the sixth, and x to the 3n. So that gives me this, but I want this, which I need to multiply by x. So I'll multiply this by x, so I'll multiply every term here by x. And that becomes x to the fourth, x to the seventh, and if I'm multiplying by x, I just add 1. So x over 1 minus x to the third, which is the same thing as x times 1 over 1 minus x cubed, I should say, equals that. So there's your series. There's 4 terms in the general term. And since this series converges for the absolute value of x less than 1, then it converges for the absolute value of x cubed less than 1, which is going to work out to be the same, so my interval convergence is negative 1 to 1. Okay, and then number 12. Since e to the x equals 1 plus x squared over 2 factorial, etc., all the way to x to the n over n factorial, then all I have to do to find out what e to the negative 2x is every time I see an x, I put a negative 2x. So 1, negative 2x squared over 2 factorial, all the way out here to negative 2x to the n over n factorial. So I can kind of look at a general idea, and I've got 1, negative 2x, 0 factorial, 1 factorial, 2 factorial, so I still have the n factorial, so that's not going to change. Okay, and then if I kind of multiply this out, this is going to be negative 1 to the n. I mean, I can raise each of these factors to the nth power. So I have negative 1 to the n, 2 to the n, and x to the n. And then we could write it without the parentheses and simplify it out a little bit. This is 1 over 0 factorial 1, 2 over 1 factorial, and this is 4 over 2 factorial, which is just 4 over 2, which is 2. So we can simplify that out. And then we have negative 1 to the n, and then 2 to the n, x to the n, all over n factorial. So there's your series. And since e to the x converges for all real x, e to the negative 2x also converges for all real x. So that's number 12. Okay.